welcome to my talk. I'm David G. I blog on dave.dev, previously of ipengineer.net, and I just have to throw out there that I happen to work for a big bad vendor in Juniper. I won't be talking about Juniper in this presentation. It's not a sales pitch, and this really is a brain dump of some kind of scientific query, quandaries, frustration, and some other kind of things I've been dealing with for the last 12 months. And all of that frustration is embedded into this deck. Now, I will say as well, part of this talk has been given at one of the Irish network operator groups. It was quite well received, lots of interest from both the scientific community and just kind of from the normal cynics. So hopefully, if you take nothing away from this, other than a bit of frustration, maybe the presentation was a success. So I've been in the networking space and the software space for quite a while now. And what kind of frustrated me early on was how everybody seems to jump to a device, run some CLI commands to try and figure out what a node in a graph was doing. And graph theory is one of those things where I'm no mathematician, I'm not an expert. I've learned enough to be dangerous. But from what I did learn, it turns out that if you apply the fundamentals of graph theory to everything in networking, then it really becomes a data traversal problem in a graph. And networking, therefore, you can see from the graphic on the right-hand side of the screen there, can be represented quite easily in a graph database. That the problem ultimately is getting data, meaningful data from those graph nodes. So that might be a firewall, it might be a router, it might be a switch. And luckily, there's lots of industry movements happening to help us do that stuff. Graphs can also contain more than just state, so we can actually contain workflows on them as well. That means we can deal with things like configuration management as well as operational states. And what's really interesting is when we start talking about self-driving. But ultimately, and this is really the title of the talk, I kind of started viewing network operations as a load of pirates going off on the seven seas looking for treasure, but they didn't have a map. And it's kind of stuck with me for quite a while that this is a weird state of affairs that we have in networking. So anybody that's done anything at all in automation, network automation, will see immediately the relationship between a graph, a cyclic graphs, as in there is a start point, a series of nodes. You can traverse those nodes and you can pass data through those nodes, or the nodes may affect the data in another system. And ultimately, they have an endpoint. Some graphs are entirely cyclic and they never exit. And a lot of software systems can be modeled like this. Some people also refer to these as label transition systems. And if, again, if mathematics is your thing, some of this is really, really quite simple. But once you start fundamentally seeing how to change a node, so again, a network device in a very, very simple way that takes part in a much larger graph, the notions of graph theory really become quite important. And then we start talking about like products and how kind of, I guess those turnkey products like Cisco's ACI, they really embrace certain aspects of graph theory. And even if you go and try and design a service, you're very much in this mode of thinking when you design these things. Another beautiful thing about this is networking really is never in an end state. So even if you're a professional services person, if you're an operations person, and you're looking at the network as a means to deliver service, as in you start on Monday, by Friday, your network better be up and better be delivering services, your exit might be Friday, but the network itself never has an end state. There are always changes, moves, adds, and changes happening. And the graphs give you a really powerful aspect here, as in you can not only model what is possible and what you need to do, you can verify that it has been done, but there's enough data embedded into the system to always allow you to move forward on this kind of infrastructure without an end state kind of approach. But the more you tend to look at automation systems and automata, and whether that's cellular automation or really just kind of like, simple element A affects element B, and there's some stuff that happens in the transition, how A affects B. The more you start breaking problems down into this space, the more I just got frustrated. So a few years ago, having conversations with kind of fellow network engineers and really trying to automate some of these things in a very meaningful way that we can make abstract enough where it's not not overly complex, but it gives us the power of things like verification and assertability and modeling. We want to be able to model these things. And it just, the more I thought about it, the more my gears got cranked out of line in terms of being frustrated. And the frustration ultimately came down to me analyzing the industry at great length and then having a bit of a nervous breakdown, not a real nervous breakdown, but a bit of an issue. Because all it seems that we've really perfected at this point is we've automated the keyboard. We've taken what otherwise would be generating some human readable and human kind of generatable configuration, and we've thrown it right into a machine, and we said, hey, automate this for us. So what have we really done? Well, we've separated the data that typically goes into a set of repetitive or repetitious commands. So we've given that over to a tool like Ansible, Puppet, or Chef. And then we have this magic module that generates and renders new configuration and pushes it down to the device. And if we look back and if we widen our blinkers in terms of this very high-level graph approach of how everything is connected and how bits of data, whether that's config data or operational data, flows end-to-end that allows us to model, all we've done at this point is we've sped up how we get config from our brains or from designs into a device. We still haven't got any real closer to automation. And Automata comes from a Greek word that I can't write or pronounce, but the rough translation is for self-making, and Ansible and Terraform and all of the current tools and infrastructure as code tools, Automata today, self-making is not. We've got a very long way to go in terms of really having that kind of the power we all talk about. But what about unit test and all these things? These are all great steps, and I'm not saying it isn't good enough, but I'm also saying it isn't good enough. From an automation point of view, I always think about things in these kind of huge kind of connected graphs, not so much as cycle times and going through tools, which leads me to some frustration, as you can probably hear in my voice. So where are we as an industry if we take these kind of viewpoints into account? Well, we have the business, and the business sits on top of a network. We have different teams managing that, and really what we've done is we've affected a really tiny aspect of our business. We've maybe sped some of our jobs up, but we haven't necessarily improved anything. We might have got a little bit more time back in the day, which might allow us to change some things, but we haven't really gained any awareness of anything around us. We've not managed to query the systems and all the systems and how they're dependent on each other. It's a bit of a poor state of affairs, really. And again, just if you're new to network automation, I'm not trying to put you off. The entry level very much is you grab some templates, and that might be in the parlance of whatever device you have. So if I think about, Cisco, it might be iOS, there might be some Junos, there might be some Vios, whatever. So we create some human readable templates. We remove the inputs. We then have host information of where the data is going to go. We have variables then that go back into the templates. That might be a VLAN number, a description. We might have some other directives, but we put all those things together. We render some config via a tool, and then we almost push blindly the device. And going back to the graph piece, we might have an instance where we have two empty devices, or we're trying to stand up a service, so maybe the interfaces on these devices, the device is doing other things, but we have two new revenue ports that we need to bring up and face each other. So we bring up a port, we stick an IP address on, so you can see inet.1/30 in the middle set of routers there, and inet.2/30 on the bottom router there. If we've done our job right, and the templates are correct, and the host variables are correct, and everything else is correct, and the tools have connected to the right devices, and the devices have accepted these human readable configs, we might get to a point on the right hand side where the link comes up successfully, but we've got no guarantees on that. And even if the argument is presented, well, what about databases, Dave? And what about YAML files where we can store all these variables? Okay, that's great, but we still don't get any assurances. All it means is if we've moved the book, somebody else more diligent now has to manage those variables further up the stack. So confidence is a bit of a problem here. Visibility is a bit of a problem, and growing this thing properly and organically, we still haven't solved. And then what really made me chuckle as part of the journey in terms of trying to describe these frustrations, I saw a Family Guy episode, so I thought, well, this is going to explain things beautifully, and it's a real gear grinder. It's been really difficult for me to kind of swallow that the state of automation is probably quite made me unpopular, maybe, especially I'm trying to kind of quest myself on social media and keep myself quiet. And ultimately, what's missing in all of our efforts around automation, it's not the next great library or the next great tool. It's a graph. It's a graph. I'm not going to swear, and it's obviously a light swear word. And the more I think about operations and all of the challenges and trials and tribulations, if we thought about things more in terms of how they're connected end to end, we'd be in a much better place. Jeff Sussner is a guy that I want to just kind of briefly talk about, and he wrote a book called Designing Delivery. And you think about problems in terms of product delivery or service delivery, not just build it, throw it over the fence and run for the hills, but how do you roll out a product deep within the business to make it harmonious? So if we're going to automate the stand up of a service on the network, we want to do that thing so it's absolutely reliable. Well, that means having knowledge of how operations might want to observe that the new service comes up. They might want to take some metrics and baseline it for the first few days to make sure there aren't any snags or any weird issues. The amount of times I've seen services come up and they've not worked, and then you pick the phone up and you have a chat with support and you get nothing but frustration. And it's really where we are as an industry. And I think we've gone so far down the path of making everything efficient and everything so damn optimal. We've missed the art as well of injecting change into the business. Which brings me right back to the graph, because if we can model everything onto a very large graph and we can see how everything affects each other, how everything is related, even operations can work on the same system. Instead of having one system for provisioning and one system for monitoring and alerting and auto remediation and everything else, I still see that businesses is massively fragmented, and the kind of traditional classic network automation approaches, where really we're kind of stuck in the lands of tools like Ansible or independent efforts. So take a Python library, write some scripts. Well, big news, lots of people were doing this with Perl years and years and years ago, and even languages like PHP. Just because we change a language, we pick a new tool up, it doesn't mean we've actually progressed. It's just the same old thing with a new name, but unfortunately it's not progression. And this is, again, it's another gripe. It really grinds my gears that we talk about dev and DevOps and SecOps and SaaSOps. We're not really improving things. We can talk about it, we can be aware of it. Having awareness and reading the books doesn't really move us any more forward. And the more I deal with this, the more frustrated I get, to a point where this is where this presentation came around. So back in the iNog days, somebody said, we know you talk about this stuff a lot. You're frustrated with this. Do you want to present it? And I daren't, because all I can do is get angry about this stuff. There's this great big black hole in the middle of every automation system. And even if we think about the road that we've trod, we talk about things like Open Daylight and but we can go netcomp from there to here. The information that goes into those systems is still quite isolated. It still comes from a spreadsheet. It still comes from an isolated database. There's no great record, system of record underneath to help us analyze, verify, and query in one kind of, and I don't want to say pane of glass, but I almost want to say one layer of normalization. And the panacea really is if we can bring all these things together and move things forward. I can't really underestimate, though, the power of being able to have that layer of normalization. And right now we can talk about JSON and XML and YAML and Python and Go and all these different tools. But all these tools and language formats and metadata types and data representation systems, they're only tiny elements in a much larger system. And I very much came to the conclusion as an industry, and when we're talking about network automation and network orchestration, self-driving, self-healing, and all these different things, that we actually lack complete ability to even describe what it is that we want to do. So I was in electronics way before I was in networking. And even looking at a little simple circuit like this, immediately you recognize the components, and ultimately you go, well, I don't need to build this to understand that the chances are this is a flip-flop circuit, and the LEDs are they're gonna flip-flop between themselves. And then you can go off and you can take the resistor values and the capacitor values, which aren't on the diagram, unfortunately, but then you could figure out the flash rate through scientific means. We don't have that. What we do in networking is we've selected a tool and everything's fantastic. We're going to pay more tax because our business is going to grow. And it's just a little bit disappointing we're not anywhere closer to solving this than we were a few years ago. And yes, there are systems out there that kind of dealing with declarative content and intent. But in terms of being able to model, drive, operate, verify, assert, and rapidly troubleshoot, we can't do those things. In terms of self-driving, how does a car self-drive? Well, we need an inordinate amount of data coming into the vehicle to be able to do those things. Well, the data is beginning to hit devices now through telemetry and standardization of data objects. So we can take OpenConfig, for instance, which is helping us to bring some taxonomy and some structure to the data that we need to be able to build these systems. But I also don't think it's a machine learning problem. A lot of people have turned around and said, oh, well, what about AI and ML? Well, do I really want to trust the, I don't know, an ISP or a carrier network? Do I want to hand the control over to that, to the equivalent of a 2 or 3 year old, just because there's loads and loads of data that's gone into those systems? Does it really mean that the decision is going to be made how we want it to be? We can't really trust those systems to be able to calculate, especially I think in one of the talks I saw not long back, one of the algorithms, I think it was one of the Google image algorithms, couldn't tell the difference between a desert and an Apache helicopter. Imagine if that's a flow spec record. Oops, we given away the keys to the kingdom. Not only have we paid more taxes, but the kingdom has been defeated. An Automata is generally a lot more complex, and this is really the bottom line. I don't like the reading from slides too much, but it's just more complex than a set of if-else statements of self-driving and self-healing. If we have if-else statements, sure, we can generate a signal that is meaningful and it has context within the bounds of the if-else statements. But when it comes to external dependencies and what other inputs that we can query for, we don't have good means of doing that without a human getting involved. So given all of this chatter over graphs, where could we be? Well, if we could represent configuration in our kind of desired state in terms of graph, and if we could take information from ops and put it back onto the same graph, we have two things. We have our desired state and a means to regulate or coalesce the actual real world devices against the config graph, and we can then keep an open loop open, or a closed loop, sorry. We can take information from the graph, we can push it down to the device, and we can verify in a check based on signals and events. So say if a commit has been received on a device, the information contained on the configuration graph, a small subsystem could do a verification. Is the configuration of the device the same as that's on the graph? And this is really quite important, because if only a small portion of the graph changes, we can also isolate parts of a configuration standards that we know are going to have changed, which is important if humans are still fiddling around with other little pieces of configuration around the edge of the network, which they're invariably going to do. There is no hard do or don't, I think, in this arena. Lots of conversations come up with to make automation reliable. Well, let's just ban the humans. Well, in that case, actually, we slow the business down because simple problems can't be solved. If you ring up a bank, I've got a friend who he took on a 1 gigabit Ethernet connection in Milton Keynes, and it turns out it was a product that didn't exist. It was kind of like a marketing product, and now he's stuck on the system and can't get off the system because nobody built the process to remove him, which is kind of laughable. But it's a good example. If we make hard and cold decisions on this, we're going to cause more problems. We have to be flexible. So the idea is, if our configuration graph is aware of the changes that it's asserting on devices, on real world devices, and there's a system that can double check for those changes, it means that somebody else can change some of the data on the system without fear of the system doing a hard reset because of a small part of configuration has changed, where the system tries to reinforce push back the last known commit for the whole configuration, which is, I think, terrifying in my mind's eye, especially if you think about ISPs and IXPs. We don't want to be in a position where we're deleting the whole configuration, regenerating, and leaving it down to the network operating system to figure out how to do the delta. And I've just realized I've talked about the config piece quite a bit there, but the whole the union between ops and configuration almost is like this kind of DevOps. If our dev is the config, and our ops is in terms of kind of this assertion, validation, dealing with failure, this kind of constant discovery and absolute knowledge of what it is that we've done from the config. We can almost look at this as a DNA system. Our human bodies is built from a small set of building blocks, but it's actually quite a complex machine when we look at it in the kind of cold light of day. And that kind of spurred me on to something else. A lot of our infrastructure is code tools. are actually really quite simple. We've took a model from a network operating system. We've then created a data type in some language. Now, whether that's been represented in another data form, it doesn't really matter. But it does quite a poor job. So if we think about this as a machine-to-machine problem, and everybody's been talking about IoT and machine-to-machine communications, well, this is one of those things. Our IAC tools, our infrastructure as code tools, don't do a very good job of talking machine back to a higher level system. There is one tool out there that does, though, and that is Terraform. And with Terraform, providing that the southbound provider that goes off and talks to those devices is being built with proper resource handling in mind, and this is not a pass-through of CLI commands or REST commands, which I've seen a few out there like that, but actual resources. So a bit of a cliche example would be VLANs. If we create a VLAN in Terraform for a known provider that handles resources, what we'll actually have is a set of HCL key values that go into the configuration for that VLAN. So that might be a VLAN name, a VLAN number, a VLAN description, plus a few other fields, maybe some ports where it's applied, but it's represented in terms of a proper resource within Terraform. Now, interestingly, Terraform itself then runs a graph internally, an acyclic graph. It organizes the resources in terms of dependencies, tells you, the operator, what it is that it's going to do, and that also might be to close a delta if there has been a change or a move of data. And then using a southbound connection goes off to a device and implements said configuration. Now, what Terraform doesn't do is there isn't a Terraform of Terraform. So we still have to deal with directories of configuration per device. But within that device, ultimately, Terraform can handle the acyclic graph. Now, I've had a couple of people say, well, you could apply Terraform to the whole network wide. But then what you've done, unless you go off and handle small changes independently, or if you go off and handle small changes independently, what you end up with is the kind of master, let's call it the umbrella Terraform, being relatively unaware of what's going on. So Terraform is great if we think about this per device. Now, the lovely thing is Terraform with a provider that's been built the right way to handle southbound resources correctly, it will tell you in JSON form about its metadata or structure. So it will tell you what fields a VLAN resource accepts or a BGP peer accepts, which becomes very interesting when we start thinking about things in graph format, because it means we now have an IAC tool that talks machine language to potentially a high-level orchestrator that understands all the capabilities that Terraform has for a given device. It's really quite an important point that can't be understated. So what happened at this point was 2.5 years ago from this point, I built a experimental Terraform provider for Junos. And it only did kind of 4 or 5 things. It did something like a VLAN, a BGP peer, an interface from a layer 3 point of view, and also applying a VLAN to an access port or a trunk port. It was all relatively straightforward. But what I managed to do was get, and this is a recent addition to the experiment, I managed to get Terraform to describe to me what it could do to these devices. And I created canonical examples of those things and then placed them on a graph almost as an intent. So the intent actually is the inputs that go to the IAC tools, but it allowed us to, or allowed me certainly, to try and start moving out of the realm of frustration into a realm of real and changing things. So long story short, I went off and probably heads down for a good 6 months last year. In all my spare time went into this. I wrote, I don't know how many lines of code at this point, probably several 100,000. It's all built on the back of Neo4j, which is a graph database. 99% of code is in Go. There's only one module in Python, and that's quite a novel element. I'll go into that in a moment. All communication that drives this graph is based on NATs, which is a message bus, well, a kind of message bus, often called an ear and mouth message bus. And Google Protocol Buffers is the means of me transmitting data between those components and gluing things together. So what we have right now or what I have right now, is a means of discovering some basic topology, which is what you see in front of you. That includes devices like cards interfaces. There is a taxonomy tree, which is not on this graph, but I think it might be on the next one, where we can pin things like state of BGP, peers, ASNs, or whatever. Really important operational information we can have in a known structure and known tree. And then we can place the desired intent onto the graph in terms of how we want our configuration. And then what happens is there's a global signal system that runs. So once I've made all these changes, I create a snapshot. Hashes are stored of all the subtrees and the trees, and then I run a reconciliation event. And what happens is system agents responsible for devices, they log into the graph, they do a query and say, right, tell me everything I need to know about the desired state of MX01. And it breaks down into small Terraform files, and then any deltas are dealt with by the agent. The agent deals with the device. It's had the signal, proceed, go make the change. And then it does a verify, comes back, and providing that the device now looks like the graph, we come back with an all clear. And you could almost look at this scientifically like an eventual consistency approach to dealing with network configuration. Now, this I can't even begin to tell you how much pain some of these things have kind of, well, how much have been inflicted on me. It took me about 2.5 weeks to write an algorithm where I can go from JSON or a JSON in a very particular format to the graph, and from the graph back to JSON again. And that includes things like cardinality of nodes. So give you an example, in a particular stanza, you might have 3 VLANs. Well, what you might have is a VLAN node, and then you might have 3 children of that node. And it's how to represent the data. And really importantly as well, some data is highly sensitive to sequence. So if the sequencing configuration and intent between the device and the graph is incorrect, we could end up with all sorts of problems. To give you an idea, if we run a reconciliation cycle for some other configuration and the sequence comes out wrong, let's say after three reconciliations, we get 3 different kinds of states, we've got a problem. So even though the graph doesn't deal with ordered data necessarily, I've built in metadata onto each of the graph nodes to ensure always that sequencing and order of data is maintained between the external world and the graph world. And that was just one tiny little problem that I came down to do. Now, there is so much work to be done on this. This is not a product. It's not something that you're going to go and buy. This is really a huge piece of research that I'm planning on. Well, I'm here giving this talk. I gave another one at NANOG to try and encourage the world to move forward in its hopes and abilities for network automation. So the things that we've already discussed, this can load infrastructure as code primitives and drive canonical examples, and there's another slide around this, but this is a bit that's written in Python. So the idea is I consume a metadata file or a structure of data, so Terraform can tell me what it can do in terms of resources. So I get a schema back. Using a bit of weird logic, I take that schema and I generate and create a JSON schema, individual JSON schemalets, and then I create canonical examples. So one of the biggest problems I think with any data-driven system is you have to go to the documentation. And the idea really should be, I want a browser-based system that I can go off and query and say, right, well, how do I create a VLAN on this system? And this is exactly what I've got. So I can go and say, well, it's this kind of device, it's this kind of resource that I want. Tell me how it looks, and the browser will actually tell me the inputs that are expected, required fields, that kind of thing. Which means then I can skin this with a UI further down the line if I have to, because everything's model derived, and it happens to be Terraform is driving the modeling, certainly from the canvas point of view, from the data structure point of view. But when it comes to self-driving, this is work in progress, and I haven't solved this yet. And I made a point a while ago, I need to go off and develop some GPU skills, because I think what we actually need for this, instead of having influx database and some logical triggers over time, the problem with that is over time, the more data that goes in, the more cardinality that you have, or that, let's say, the different fields of data that you have going into that database, the disk IO just massively increases and climbs. CPU just kind of rockets up, and we've got a scalability problem. And I'm not talking about what everybody talks about, how to make this thing internet scale, but the problem is for us, networks and the amount of data they can emit was already becoming to be a bit of a problem with SNMP anyway. But with telemetry, where we can stream data every 5 seconds, every 10 seconds, it's a huge problem. And what I'd love to be able to do is consume all of that data in this kind of actor framework. So it's a stream-based real-time processing system, massively parallel with streams and things talking to each other. And I'm of opinion, and I'm really kind of running out of time to go any deeper on this, but with some GPU processing, we can take that telemetry information, pre-cook it almost like you would with a routing algorithm, and then take the metadata and put it back on the graph for analysis. So I've got a huge amount of work to do on that, and also creating relationships between config and ops. I've got the algorithm sorted out now. I just haven't got around to implementing that piece. So where we could be is, I think, a much better place. If we had this treasure map, there is a whole pile of treasure that we could go after here just as an industry. I think it'd be absolutely amazing. Telemetry is emerging. We've got open config models, which are slowly kind of getting there. We've got protocols like BGP monitoring protocol, which are really, really helpful. We can go templateless. We can throw Ginger 2 away and all of these kind of horrendous workflows that just automate the keyboard. We've got machine-friendly data, which means our tool chains can be a lot more reliable, especially as a system can describe data to another system. Fantastic. We can remove humans from jumping on devices and removing those CLI checks and really just kind of removing the burdens of going device to device. We can go off and query the graph for these kind of relationships and how things are interrelated. We can have a tight control loop between what we want and what we have, meaning we can put our kind of intent onto the graph, feed that into infrastructure as code tools, and have an external agent reconcile that almost in real time or through signals if you need to pin things to things like maintenance windows and management. And then it really gets to this point where we can actually do a proper event driven, not just event, well, interface has gone down, go do something, but we could actually have very complex and actual, I guess, I don't want to say actual ML, but we've got at this point enough data points and enough data over time where we can feed them into algorithms to try and get a sense of, well, this is abnormal. Is this an abnormal thing that's just happened with this interface? And give you an example, CCTV now has this. So if you have a car park outside of your office or home or work, and nobody hangs around there, but all of a sudden a load of teenagers come along and start partying on the back garden, even right now, or in the car park, sorry, I'd say back garden, even now, you can push out algorithms to cameras for that, and the camera will say, hey, there's some abnormal behavior going on here. I don't know what it is, but go take a look. We could be in that position with this level of awareness. It could actually be really quite fantastic. Bit of a screenshot for you here. So everything I'm building, it's all on web kind of standard stuff. So there's a Swagger API. This example that I mentioned, I can go and query the system for resources. So I'm querying it for a device type of QFX. Again, sorry, I work for Juniper and I've got access to those devices. A resource name of type VLAN. And on the bottom screen there, you can see the resources that have all been returned that have got VLAN or something to do with the VLAN. From the query, and you can see all the information that goes into those resources. Again, this is a machine schema, something that we can verify and validate. We don't have to go off guessing or worry about software upgrades. We can just onboard a new infrastructure as code Terraform provider and deal with it as and when. And then from an operations point of view, where I want to get to between orchestration of Terraform resources and operational data is kind of what you see here. It's a little bit hard to see, especially the speed that we're running through, but even the relationships are named, which gives us this huge capability. So it means we could actually go, well, what does a path look like from the QFX01 device if down the orchestration branch, and what resources lead me to gigabit Ethernet 000. And we might find actually there's a piece of configuration and a piece of operational data that aren't connected. And that might even mean that we've accidentally put the sub-interface in the wrong VRF, for instance. And this is exactly what I've just described here. This is a bit messy. You have to constrain your thinking a little bit, but it gives us this normalization layer, something that's not special to be able to deal with a very connected thing, this network that really shouldn't be islands of independently managed devices. We can pull out the right level of information and the right level of intelligence from these devices. And at that, I'm out of time. I realized I've packed way too much into this presentation. Again, this has been a privilege and an honor to present. I was certainly, my heart jumped to beat when I saw the message that the talk had been accepted as well. So thank you for listening to me rant on and dream on about everything that's been going on. I'm more than happy to chat and answer questions. Again, thank you. You can email me at dave.dev or at _IP engineer on Twitter. Thank you again.
Good morning, good evening, good afternoon. Thank you, David, for that wonderful talk to start our morning and afternoon off. we're going to go right to the Q&A section, and we have approximately 5 minutes. And there are already 2 questions in there, and David has indicated that he sees those. David, if you want to go ahead and answer those for the gentleman.
Sure. Yeah, thank you. So the first question, what are the shortcomings of the existing tools and the libraries that do support graph models and operations? What is most needed to mature this space? I'm going to answer that one backwards. I think from a maturation of this space, working groups in communities exactly like this. I think if we could community source kind of operational insight and experience and turn those into practices, I think we could see a great deal of good being done instead of it coming out of the standards bodies, something like the ITF. I think it'd be great to have some of these things crowdsourced. I think this is a very early space. There's lots of good things going on. I think the danger with some of this is considered secret source for some organizations. Even the research that I've been doing on this is not talked about a whole lot. So I think that'd be great to do that with the community. Shortcomings of existing tools and libraries and those that do support graph models. Well, libraries, other than using pre-baked off-the-shelf products or kind of open source platforms, Terraform is great from a graph model perspective, from infrastructure as code and modeling resources. From an operations point of view, I'm not aware of a whole amount of tooling out there from a graph perspective. I'd love to be able to take this offline and do some more digging on that. I'm going to jump to the second question, also from Michael. So thoughts on persistence for graph systems, a graph database is necessary. So I'm going to answer that one immediately. So graph database is necessary. I've experimented with and without the graph systems. dgraph requires a schema. Arango had poor support for Go the last time I checked into it. And the library I'm using is Neo4j under everything, using Cypher natively and a Go library attached to that. Are they really necessary? I think you can achieve a great lot with relational databases. And actually, even the kind of early work that I've got is backed by several databases. So there's Neo4j and there's Postgres, and there's also a key value store as well, and I'm doing all sorts of interesting things, like there are relational tables, and what I'm doing, I'm basically modeling subtrees, hashing them, and then doing kind of reference checks as the graph changes. It's a bit hard to describe in a couple of minutes. I do think they're necessary for finding the best path between nodes, especially if we're trying to kind of reconcile configuration against operational state, take a computation away from that, maybe turn it into an externalized event. So I think they are necessary. I think you can do a great deal without them, though. But I've got to kind of put my stick in the ground on that one. And then graph models and logic moved into the services. So I think I've answered that. I think that was pretty much one question. I really want to go back to this, the maturation, though, of the space. And if anybody is interested in this from this community, I'd love to either work with NANOG. Maybe we can put some kind of a working group together, work offline on this. Certainly, we can exchange information. I think there's a huge amount of promise in this space. I think there are no more questions on the Q&A list. So
thank you, David.
Any more?
I appreciate your response to the questions that were asked. Thank you for your presentation again.